All right, we're going to do a quick recap video from a live stream that we just did because the audio was out of sync, and that's annoying. Hopefully that's fixed now. So just a quick recap before we do a Tristar repair. We talked about different cables and how it's important, why it's important to use either original Apple cables or bona fide certified, made for MiFi certified cables. So these two cables that I bought both claim to be MiFi cables. They both have that little Apple made for iPod, iPad, iPhone logo on them. But when we get them under the microscope and chop them up, we can see that that's not the case. So I want you to know what to look for, and you really do need to dissect your cables if you are a supplier, a cell phone repair shop that are selling cables, because the cheap cables have no voltage protection built into the cable, and they can and do kill phones, or at least make them not charge if you are unlucky enough to happen to have a surge while you're using an unprotected cable. So let's look at what that looks like under the microscope really quickly. So here is one that we dissected. This is one I bought on Amazon as a MiFi certified cable, and it is a bona fide MiFi certified cable. So we can see that it has the board here that is sold by Apple as part of the cable certified cable program. So if you sign up with Apple to sell certified cables, you get this board. It costs about $4, but it has both the E75 chip, which is the thing that negotiates the interface between the device and the cable. So the E75 chip has the ability to tell the phone, i.e. the listening chip, the Tristar chip on the other end, hey, I'm a bona fide certified charger. I'm going to send you 5 volts. I promise that I'm going to do a good job keeping that voltage nice and clean, so let me in. And Tristar says okay. So E75 is the chip that negotiates that message. It also has the ability to apply logic and to be used as for any other device, like your like we like to use the example of your plug-in Apple certified karaoke machine. Might use this same connector to plug into your phone and power a karaoke machine or a fan or a light or whatever. The other important chip, in fact more important, is this square one here. That guy's got to be there. This is an NXP branded chip, and NXP has been making chips for a long time. And if you look up the data sheet for this guy, you can see that it's one of a family of load switches that do a great job of sending a clean voltage, a clean charging voltage to the device. It has overcurrent limiting, it has over voltage limiting, it has reverse voltage, reverse polarity protection. So all of that is built into the chip. So that chip is there, and that's what gives the charging cable itself the ability to protect your phone from voltage ripple, voltage surge that can damage the Tristar chip. So that guy's really got to be there. Let's compare that to one of the ones that we dissected, also sold to me through Amazon as a MiFi certified cable, but when we opened it up, it clearly is not. So here's this guy, which has, this is the standard appearance of the cheap cables. These are the knockoff Chinese manufactured cables. One of these guys is the fake E75, who can just send the message, hey bro, I'm a legit charger, trust me bro, please let me in. And the other one is going to be the cheap, cheap as you can get load switch, which may not, in fact, probably doesn't have any kind of voltage protection in that chip. It's probably just a couple of transistors inside there. And so when you combine that, the E75, hey, I'm legit, with except I don't have voltage protection, the device, there was some evidence, we looked in the live stream at the schematic, when you look at the Tristar chip, the listening chip, that chip may be actually turning off some onboard, on-device voltage protection that might natively be there while you're walking around with your phone. If I'm walking around with my phone with nothing plugged in, then there's protection in the phone for static or anything that might kind of interact with the charge port that's not a charger, and that voltage is just shunted to ground. So that protection may in fact be deferred by the device to the cable because the device believes that it is, in fact, a certified cable that has voltage protection in the cable. So the bottom line here is that you need to either use original Apple cables or ones that actually have the bona fide Apple produced made for eye connector. And there's a couple different flavors of these, but they're all going to look pretty much the same, where you'll be able to see that big square NXP chip in addition to the E75 chip and some other guys that are on that board. I'll put in the links below, my link to the cables that we use here in the shop. We use the Anchor brand certified cables that we have dissected, and we really like the cables. We think that they're very durable and they last for a long time. So that's the ones that we personally use, so I'll provide a link to that. And then I'll also give a shout out to the folks that sold me the bona fide cable. This is the one, Rav Power, that I'll provide a link to, the one that I actually bought that I have now dissected and confirmed. And if you guys are shops and you want to vouch for a, hey, I bought this and I have dissected it and I can confirm that it's a bona fide cable, then let me know in the comments and maybe we can get some links together to see if we can do a better job at getting these cheap, crappy, and fake and misleading, lying to you cables out of the marketplace, or at least go leave them a bunch of bad reviews. All right, so with that being said, the consequence of using one of the cheap, gas station chargers in your phone is that you can get damage to the Tristar chip, and that's going to present in a bunch of different ways. It could present as a dead phone, where the Tristar chip has some ability to connect with the CPU and sort of be on the whole phone PA system. And if Tristar is damaged in a way that brings that line down, then you're going to have a dead phone. The CPU, is going to be saying, all right, everybody turn on. I want to have this chip on. And if that message is, then you got a dead phone. Other examples of Tristar failure, depending on how it kind of gets a punch from the charger voltage, could be that you have accessory not supported when you actually have when you know that you have a bona fide cable, you've gone back to the bona fide cable and it says accessory not supported. It could also be fake charging, where it detects the cable and it says that it's charging, but it actually doesn't pull any charging current and the charging percentage doesn't go up. It could be not detected at all, so you plug it in and nothing happens. Or it could be sort of like rapid battery drain. If there's a short inside the Tristar chip, that'll get really hot and you'll lose battery life through Tristar, and a couple other sort of less common weird very specific failings. So the tool that you use to kind of assess Tristar function is the USB amp meter. Everybody should have one of these. Every household should have one of these. You should sell these in your stores because this is a great way for end users to know whether or not they have like lint in the charge port that they can clean out, or if they have a bad cable or something like this. So this device plugs into a charger and it can tell you whether or not the device is pulling zero charging current, low, or normal. And that's a real must-have for any consumer electronic. Every house should be able to know whether or not the device is charging and when it develops a charging problem. All these cables are going to eventually fail, so having your eyes on that really helps a lot with troubleshooting. So let's take this phone here. This is an iPhone 6s. One of the questions that I get a lot is, is there any way to diagnose a Tristar failure? We covered that a little bit in the live stream, where the answer to that is, if you look at the schematic with the Tristar chip on it, it does a whole lot of things that are mostly data chatter. So what's the tool that we can use to assess whether or not data on a line is normal or not? And the answer is the oscilloscope, which we practically never use in cell phone repair. So in order to assess a data line potential problem, we would have to know what the data is supposed to look like. So that would mean taking a known good version of the device and finding test points, or if you're not lucky, having to lift the chip and solder into a ball under the chip, put the chip back on, get wires out, attach them to an oscilloscope, prompt the phone to boot or charge or do whatever, and look at the actual data communication on the oscilloscope. Then you'd have to kind of come up with a known good set that's supposed to look like, and then you'd have to do the exact same thing. You'd have to solder wires on, you might have to lift the chip and put wires into balls, put the chip back on, in order to just diagnose, okay, yes, this is not normal. That's a lot of work when the reality of changing a Tristar chip just as itself a diagnostic tool is very, very straightforward. Changing Tristar for most phones is maybe a 5 or 10 minute job. So let's walk through using a Tristar chip change as a diagnosis for this phone. So I have an iPhone 6s that is here for won't charge. Phone not charging. Seems like a chip problem, but not sure. All right, fair enough. So let's find out. So like all board repairs, we're going to start everything with known goods. So I have a known good 6S battery, a known good 6S dock. I've taken the board out of the phone. And before I do anything, I want to verify that this isn't just a parts problem. So I don't want to go operate on a phone if the reality is it just had a bad dock. So I'm going to rule that out sort of all at once with my known good screen, known good battery, and a known good dock. So let's connect all this together. And then what is the tool that's going to tell us whether or not it's charging? We're not going to listen to the device because it could lie to us. We're not going to look at the device's charge percentage and believe that. The one tool that tells us, is it charging, yes or no, is our trusty USB amp meter. And I'm going to put a link to this as well. These are inexpensive and everybody should have lots of them. Okay, so let's see what's going on here. I see that it is detecting that I plugged something in because I see an Apple logo there. And I can look and I see that I have 5 volts coming out of my charger, but the current down there, the blue, is 0. So it's not charging. It's actually not charging. Let's see if it can boot up all the way or not. But this seems to be fairly diagnostic for, yeah, this thing has a board level charging problem. Now, we could get a multimeter out and to start ask questions like, well, is the current getting from the port here, the dock, is it actually making it through to the Tristar chip? And maybe it's not, and we'll figure that out if we need to. But where I like to start is just sort of with a signature failure. So in a phone that has no other damage and it suddenly doesn't charge at board level, that is 90% of the time a Tristar problem. So changing Tristar itself would be my diagnostic step. Let's see if it can wake itself up. So I'm connecting and disconnecting here, and it doesn't seem to wake itself up here. Let's see if it's detected by iTunes just for fun. So I'm plugging it into the computer. And I don't hear any detection. So something's up with its USB interface. And my first step would be to replace Tristar, and then we'll go from there. All right, so when the iPhone 6s Tristar is on the bottom of the board, and let's go on a hunt for it. I'm going to put a little bit of heat to just pull up the sticker shield, just so that it can come off nicely without getting all ratted up. Since I'd like to repair this to be a phone again, I want to try to keep it as unmessed with as possible. All right, so with that little bit of heat, this sticker comes off pretty well. I'm going to hang on to my sticker. All right, let's go on a hunt for Tristar. All right, so here it is right here. Now on the 6S, Tristar is hiding a little bit under this bracket. And so now my choice is I can lift these antennas and I can cut this bracket a little bit to give myself some more clearance. Or, and I've never done it this way before, I'm going to see if I can actually change this chip, leaving that sort of natively intact. Before I change the chip, I want to look at the chip's orientation, and I see the dot. The dot is right there, so I'm going to remember that. And let's go ahead and give it a try. Before we put heat on a board, we're going to look around to say, is anybody going to be bothered by heat? And that means I'm looking for underfill. I don't see any underfilled chips, but the NAND itself doesn't really love heat, so I'm going to stick some kind of a heat sink on the NAND chip. And I'm just going to put flux on this area and go to my sort of general desoldering temperature, which is up for you to figure out for your machine. I'm not going to, doesn't matter what my machine is, it's what your equipment is. All right, I'm going to, I think, let you guys see this a little bit more clearly. All right, so we're just going to take this chip off, and hopefully I'll be able to pick it up even though I've got a big old piece of metal right there. So this is just a little bit of finesse that we're going to try and see if it's easier or harder than actually taking the bracket off. I don't know the answer to that. So I'm watching that bubbling. That looks normal. I'm listening to the sound of the airflow on the board. I'm waiting for it to kind of give a little bit. There we go. I've got movement, so I'm going to take my airflow away, and I'm just going to slide it out from under there. All right, so there we go. So we took the chip off. And let's see what we can do about these pads. I'm going to flip my iron on. Normally I like to go for a big, wide iron, and my goal here is to just kind of flatten the pad so that I don't get too much mixture of the existing solder with the new chip, because the new chip will be bringing in its own solder balls. So for this one, because that bracket's still there, it's going to give me a little bit of a hard time. Let me turn it onto the big iron instead of the mini hot tweezers. Wait for the beep. And let's see what I can do in here. I definitely don't want to disturb any resistors. Resistors generally need to be there. Just want to flatten these balls a little bit. I can't really quite get under there, so now I'm going to switch over to my mini hot tweezers. Add a little bit more flux in there, and let's see if those guys can give me the clearance that I need. They're on. Alright, I'm going to look in that corner and see if I was able to get under there. I was kind of blind. Alright, looks good enough. Nobody is really staring up at me as a giant mountain. So I'm good. I don't need to really obsess about, are these pads exactly flat? None of that is that important. I just want to kind of do what I can to remove, just flatten the balls. That's my only goal. Flatten the balls. Let me peek under my corner again. Good enough. Okay. Ready for my new chip. Let's put on some flux. And that'll spread out with the heat. Grab a new 1610A3 chip for the iPhone 6s. And now I gotta remember where my dot was. I'm also planning to make a companion blog for this sort of charger stuff. Alright, it goes more or less like that. I'm gonna take advantage of the fact that I've knocked these resistors to really let that kind of be a tell. when this chip is soldered on. Back with my heat and my heat sink on the NAND. So I put my heat sink back. I always knock that off as soon as I take the heat away because I want to take the heat away with it. All right, now let's see if we can get this to dance on its own. And I'm going to come in here with my other tweezers, and once these guys get hot, I'm going to try to separate them. I'm watching the bottom of the chip. I can see a little row of pads, and I want to see the chip jump over and cover that up by itself. All right, that looks good. I'm going to give it a knock so that I can know. There, I nudged it so that I know that it broke the surface tension on the area that is there under that bracket without me actually having to kind of put heat there. That bracket will serve as a little bit of a heat sink, so I wanted to make sure that the heat transferred under there, so that's why I nudged the chip, just to break that surface tension so that I don't end up with sort of a head-on-pillow effect on these balls. All right, and so that by itself is, now we did a diagnostic test. So that is, however long that took, felt like it was about 5 minutes. That's our diagnostic test. So if now the phone works and charges, then we're done. And if not, then we need to hit the schematics and start following those lines and try to see where we're losing our charger voltage, since we have kind of ruled out Tristar. All right. So I want to let this kind of cool down a little bit. So I will hook up the port and the screen just to kind of be ready. And then once it's cooled down a little bit, then I will see if we've made any difference. So the resistance in the circuit is different with heat. You can measure that with your multimeter. And I just need to let this cool down enough so that it doesn't feel like it would give me like a weird heat reading, something like that. So this will have to kind of hang out. And what do we have to talk about? Snowing in Rochester today. Snowplow just went by, even though there's only an inch of snow out there. All right, that's about all the patience that I have for that. So I'm connecting the battery now, which will apply a voltage to the board. Okay, now let's see if that made any difference. All right, so I see, haha. How come you can't see that? Why is that light going off? There we go. So that's normal charging current. It's pulling about 1 amp. And now I see that I have my green battery, my lightning symbol, and it's at 91%. And I can see that it is pulling normal charging current. So there you go. That's solved. And I can kind of let it sit here, charge up. I'm going to reassemble this phone back with its native battery, and I'm going to just make sure that it can charge a stone dead battery. But this is solved, you know, and it really makes sense that when you combine the knockoff chargers with a car charger situation or a surge or any kind of you turned on the hairdryer on the same circuit and you sent a dirty voltage up to your phone, it kills the Tristar chip. And in this case, it killed the Tristar chip in a way that it could absolutely not charge. It did not detect plugging in the charger at all, and now it definitely does, and it is pulling normal charging current. You can see that's going down because this battery is quite charged. And when we plug in, it recognizes that, and I would guess that it will recognize it on the computer. and I hear that detect sound, so now that's solved. So there we go, iPhone 6s not charging, solved by a 5-minute change of the Tristar chip. Even that, you don't have to do it if you stick with the certified Apple cables or the bona fide certified made for iPhone, iPad, iPod cables. So there you go.